So we look at calculation of net present value. Now we say the net present value of a project is just the differences between the present value of cash inflows and the present value of cash outflow. So simply put, we say our net present value is giving us our present value of cash inflow minus our initial cash outlay. When we say cash outlay, what we are trying to say is the cost of the investment, amount of money we are putting into this project. So we can also write it as net present value is just the present value minus cost. That is cost of the investment. That is it. Okay. Now for series of, let's say we want to undertake a particular investment for a period of time, let's say 4 years. The net present value can be given as 1, our present value. And remember we said in our previous lesson, we said the present value is equal to future value 1 plus r raised to the power n. So we are going to apply this here. Remember, the formula is saying to find the net present value, you need to find the present value. So our present value, our future value 1 for the first period, 1 plus our r. Then we have our 1 here, that is for the first year. Then future value 2, that is the cash inflow for the second period. Then is the power 2, that is the second period. Then we have future value 3, 1 plus r raised to the power 3, and so on and so forth. Then once we are done with this, the whole of this minus your I. Your I is your initial cash outlay, will now give us net present value. That is it. So our R here, where R is our discounted rate or cost of capital, we call it the cost of capital in percentage or discounted rate. Yes. And then our FV is just the future value or the cash inflows. That is it. And then normally we will represent this by n, where n is our period. Then the I you see here is your initial cash outlay or initial cost of investment. Okay, now let's consider 1 or 2 examples. So example, we have this. Let's say we have calculate the net present value of the following project. Requiring an initial cash outlay. An initial cash outlay of 20,000 and has no scrap value. After 6 years. Okay. The net profit after depreciation. And tax. For each of the net profit after depreciation and tax for each for each of 6,000 for 6 years. I think the net profit after depreciation and tax for each year is 6,000 for 6 years. Assuming the rate of return is 8% So here, what are we looking for? It's a very, very simple question. We say calculate the net present value of the following project requiring an initial cash outlay of 20,000 and has no scrap value. When we say scrap value, if we decide to dispose of the project, be it maybe investment in machineries, if we decide to dispose it of, the amount of money, that's the scrap value. After 6 years, the net profit after depreciation and tax, we always always make sure the profit that is being given to you in a question is after depreciation and tax, not before. If you are given a question and you see before depreciation and tax, then meaning you have to calculate the depreciation and subtract, calculate tax and subtract, then your final amount becomes your net profit after depreciation and tax. But with this, we already have it given in the question, so no need for calculation. It's 6,000 for 6 years, assuming the rate of return is 8%. That is the cost of capital. So what do we do here? It's very simple. We know our present value as something like this: 1 plus r raised to the power 1, 1 plus r raised to the power 2, 1 plus r raised to the power 3, 1 plus r raised to the power 4, future value, 1 plus r raised to the power 5, future value, 1 plus r raised to the power 6. So the future value, that is, we are expecting what? The cash inflow of what? 6,000. That is in future. So after 1 year, we have 6,000. So 1 plus our R. Remember, your R is the 8%, which is 0.08. 8% means 8 over 100, and 8 over 100 is 0.08. Then we have same 6,000 each year. Remember, 1 plus 0.08 raise the power 2. You see this raise the power 1. You can decide not to write. Then 6,000. Amma can decide to add 1 plus 0.08 to give 1.08 raise the power 3. Or you can choose to write it 1 plus 0.08 raise the power 3. It's just the same thing. Then we have 6,000, 1.08 raise the power 4. Then we have 6,000, 1.08 raise the power 5. We have 6,000, 1.08 raise the power 6. So we sum up all of this with our calculator. So on our calculator, we have 6,000 divided by 1.08 raised to the power 2 plus, you can do it all, like just put everything together just to save what? Time. If you want to do it separately too, that's fine. So after this, I have 2,277 37.8. So 27,737.28. Now this is for present value. Remember, we said what? Net present value is equal to your present value minus what? Cost. So here, therefore, we can say our net present value is our present value minus cost. When we say cost, that is our initial outlay. So what is our present value? 27737.28. And what is the cost of the investment? Second question investment is 20,000. So this will give us 7,000 737.2 what? 8. So that is it. Now, should we accept this project or not? Now let's come here. It states that accept the project whose NVP is positive and reject the. So you'll see that here our net present value is positive, not negative. It's positive. So since it's positive, what do? We accept this what? Project.